Welcome to our session on how to manage secrets on AWS. I need a little bit of participation of everyone here. So raise your hand if you have some sort of database on your enterprise or your company. That's good. Probably everybody here. Raise your hand if you are using some sort of credentials, username and password to access that database. Now, a tricky question for you. Raise your hand if you are rotating those secrets or those credentials regularly. I see just a few hands up there. Now, let me talk a little bit accounts. Raise your hand if you have, like, say, 10 AWS accounts. Good. Raise your hand if you have 100. There. Okay. Let's stretch a little bit. What about if you have 1,000 AWS accounts? Okay. Few hands. Okay. Last set of questions here. Let's talk about secrets. Raise your hand if you have 100 secrets to manage. 1,000? Okay, let's go all the way to 1,000,000. Who has 1,000,000 secrets to manage here? There. Okay, I don't see anybody. So my name is Eduardo Patrocinio. I am a Principal Solutions Architect at AWS. We are very happy to have you here today. What we are going to talk is about how to manage secrets on AWS, specifically to talk about how Capital One is doing that. Along with me, I have two of my friends. Sunny Wong is a distinguished engineer in the cyberspace at Capital One, and Arkashay Agrawal is a senior product manager at AWS. So the agenda for today is that we are going to start talking a little bit about the context and the requirements that we have for the implementation of Secrets Manager at Capital One. And then we are going to talk about three different aspects there. The first aspect that we want to talk is that how we are doing a centralized management of those secrets, but still have some sort of federated storage there. The second aspect that we want to talk about is how we can rotate or how we are rotating those secrets. And finally, we are going to talk a little bit about how we're implementing resilience on that solution. So to start on that is that I'm going to invite my friend Sunny to talk about the context and the requirements here.
Good afternoon, everyone. My name is Sunny Wang, and I'm a distinguished engineer at Capital One. At Capital One, we are all in the cloud like no other bank out there, which enable us to create exceptional user experience for our customers. As a distinguished engineer in the cyberspace, I focus on create secure and robust identity and access management solution for Capital One. Oftentimes use native AWS services. Today, I'm excited to share with you guys our journey in designing a robust secret management solution built on top of AWS Secret Manager, together with my partner, Akshay and Eduardo, who just talked to you guys a moment ago. Each of us will cover one aspect of this solution. In my part of the presentation, I'm going to talk about business context, key requirement, and kind of how the security aspect of that. Let's start with business context. Just now, Eduardo asked you guys a few questions, and then one of those two key questions is how many AWS accounts and how many secrets do you guys manage in your organization? And I can see very, very few hands raised up when it gets to thousands of accounts and millions of secrets. Literally don't see that many. But that's actually so different in Capital One. We manage thousands of AWS accounts and business applications. And we organize this AWS account thousands into one AWS organization we call master organization. And then we also have these thousands of business applications usually deployed in one of these accounts we call application account. And then all these application accounts needed to call one another so that it serve our customer for some specific need. So, and then we manage millions of secrets that include the API key for this application or API token for this application to talk to each other, right? And also some of credentials could also include database credentials, so that this application can talk to the database. And another context is Capital One treats security and compliance very seriously. Just like our CEO says, risk management is our number one priority. It's our business. So to meet those compliance and security requirements, we keep secret rotation all the time. And we want all secrets to be located in our target state. And then also, we enforce many best practices, including we purge dormant secret frequently when it's not used for like 6 months. And because this solution is such a critical infrastructure, we also want to make sure it's highly available so that if application fail, this solution for some reason fail in one region, it's going to fail over to another region within minutes. And one last context is this. In this solution, we only talk about machine secret. Machine secret is our secret credential that used by application or services, AWS service, to authenticate with another application. And human secret are secret that used by human to authenticate against application. Given this context, we identify 3 key requirements for this solution. First, security. We want all the secrets to be created and managed centrally through a set of API, even though the secret will be stored in application accounts. And you all know why we want to do that. And also, we want to enforce multiple layers of security to keep our secret safe and secure from its creation to deletion throughout all its life cycle. Second, we want to make sure all the secrets can be rotated as much as possible. And my partner, Akshay, going to talk about how we are doing that by using a framework we develop so that each application can implement its own rotation so that the central team, secret management team, don't have to implement rotation for every secret. How to rotate normally, only the application team knows how to do that. Third, resiliency. We are using natively capability from AWS Secret Manager that allows secret to replicate from one primary region into multiple replica region. And we build on top of that to provide active deployment using Amazon Route 53, so that if any region fails, it will quickly, almost instantaneously, all the traffic will be redirected to the other region, and it doesn't impact all the applications that need a secret from. Now let's talk about our centralized management with federated storage. As you can see, there's a rectangle on the left of the screen, the diagram called gatekeeper account. And then there's another rectangle on the right. We call it application account. So from this solution perspective, even Capital One have thousands of AWS accounts. We see it have fall into these two categories. One is one single account that we really keep close eye on it to make sure it's used properly, and only we enforce the boundary layer so that it's tightly secure. And this account we call gatekeeper account because we deploy a set of API that is gatekeeper. If any secret that need in any application account, it got to go through this set of API and to create in the target account. And this set of gatekeeper API consists of a few components. First, it has a set of management lambda that going to assume a role in any application account and do any secret creation or operation in the target account. And then we have a second component, Amazon, based on Amazon DynamoDB, they're going to keep all various metadata about the secret. Not about secret value, but almost all you can think, all kind of metadata about the secret, including its type and its owner, all that kind of metadata about the secret. And then we front the management lambda so that it is both as an API, right? And then we also build user interface, consume this API, so that our application team and developers don't have to remember all the syntax in order to call this API. And to create a secret, a developer will specify what application account they want to create a secret in, and what the region, and which region to replicate into. And then it also going to specify a list of iron rows that can read this secret. Only this list of iron rows can read this secret. So, and then we talk more about how we enforce that. And then also it provide a parameter, other parameter like how often you want to rotate the secret and other configurations. And then after that, the API going to trigger a management lambda, right? And then it's going to go and create the secret in that application account, and then configure the secret properly, including tagging it with the right value, and also set up its resource policy so that it will be safe, secure, and enforce that only the specified list of IAM role can read this secret. And we'll talk more about that in later slides. So once the secret gets created in application account, then the secret can be consumed just like any secret got created in any other way, like directly through management console. That could include AWS service like RDS proxy, or any application deployed in Lambda, EC2, or any other way. So you may wonder, why do you go through all this trouble to create a set of API why not just letting use and create secrets directly from management console? AWS provides a very user-friendly management console to create secrets and do everything like that. And agree, for many companies, that may be the right way to do that. However, for Capital One, we have to do this because we have thousands of accounts and millions of secrets, right? And most importantly, we want to provide the assurance to our regulator and auditor so that they know the secret got created from its birth, that is secure, safe, and then throughout its life cycle. And then we can also answer any question at any time that our auditor or regulator will ask. For example, if they want to say, hey, how many secrets are used to do this thing, right? Then we can quickly just, all the metadata to answer that question is stored in DynamoDB. Because every secret goes through this, and we know, right? And also we can answer other questions if to auditor saying, oh, how many secrets haven't been rotated beyond 60 days, or things like that. So it really, we believe with this centralized management API, we would be able to meet the security and compliance requirement of in such a highly regulated environment like Capital One. And importantly is this. Even though we manage all these secrets through a central set of API, they are stored in federated way in each account, local to where the secret will be consumed. And it really provides multiple benefits because of that, right? First is local to the account where it can be consumed. So it's minimum latency and highly performant. If you store in a central account, then it got to go through account boundary, all that, right? And also that's not something we want. So we store directly in the application account. And also, it has a second benefit like small blast radius. If one secret in one account gets hacked, then it only affects that account, right? And then the third, it also addresses server limit if we put everything into one account, because we have millions of secrets. AWS probably won't allow us to put in one account, then it's not just going to exceed the server limit, it's also going to kind of cause a bottleneck when you consume those secrets, right? So I don't know how do you guys going to have similar kind of requirement like Capital One here, but I think that hopefully this going to give you a couple consideration when you try to adopt secret manager, and when you can think about how you're going to create and how you're going to store, and what mode you're going to put that in. In summary, centralized management with federated storage really make sure that Capital One can meet the compliance and resiliency requirement. Next, we're going to talk about multi-permission access control model. But before that, I want to give an overview of how a couple policy, 3 of them, that we use to secure secret at Capital One, how they work, and how the AWS evaluate them together. This is going to lay on is laid a foundation for you to understand the slide next. That we're going to look in detail how Capital One keeps the secret secure with multiple layers of security built in. So first, we use service control policy. Service control policy are policy you apply at account level or the organization unit level, right? It defines the maximum permission each account can have. If you attend the section that my colleagues, Roland and Chris, talk about data parameter this morning, many of those guardrails is put on the service control policy level and the account level. And this very important to understand is this. Service control policy defines a guardrail. It defines the maximum permission, but it doesn't grant permission. So keep that in mind. Second is identity-based policy. We also call IAM role and policy. And those are mostly common used for many, many companies, right? And for many AWS services. This policy are attached a user identity like a user IAM role. And then it defines what this AWS principle can do on what resource. And the third, resource-based policy. We also call resource policy. These are set of policy you attach on each individual resource and define what kind of action some principle can do on this resource. And this actually is very, very critical for our solution here. And here is why. Look at how the diagram shows how AWS evaluate all these three policies together, right? So it goes through two phases. First phase is deny evaluation, right? So for service control policy is deny there, right? You're going to look at that. What's deny policy appear in that. Also look at identity-based policy and look at any other deny there. And look at the resource-based policy, look at all the deny. So it put together, it evaluate what you want to do through that three policy. If there's any deny, then it's going to, the final decision will be deny. They call explicit deny. So let me give you an example. For the secret that we're talking about today, right? It allows you to put a resource policy on it. And then if the resource policy is saying, no other IAM role can access this secret, can read this secret, unless for this Lambda execution role. Then it's like any other Lambda function cannot read the secret from this secret. Doesn't matter how much they assign the permission to the Lambda execution role, as long as it got denied on the resource policy, it will not be able to read the secret value. So keep that in mind for the next slide. And then the second phase is permission evaluation phase. So it's going to evaluate all applicable identity-based policy and resource policy. No SCP, no service control policy, because service control policy more about deny, right? So evaluate these two policies and look at, is there any explicitly permission allowed? And then if it doesn't have explicit allowed, then it will be implicit denied, right? The final decision will be implicitly denied. But if there's any explicit allowed, then the final decision will be allowed. So next, we're going to talk about multi-permission access control. And one concept I want to call out is, this is specific to Capital One. We define a human IAM role and machine IAM role. We categorize every IAM role and using a name pattern saying, human IAM role are used by developer to to log into AWS Management Console and then perform manual tasks there. Those IAM roles we call human IAM roles. And then machine IAM roles are used by application and services to do things. So you assign to a Lambda function or an EC2 instance. Those IAM roles are called application IAM roles. And why we want to differentiate this? Not just for secret. For many services, we do that differently for human IAM role and machine IAM role. For secret, because this solution we only manage machine secret. So we're saying only machine IAM role can read the secret in this solution. So on the SCP, we deny all access to human IAM role based on name pattern. So this put a very good guardrail to ensure the secret in this solution not going to be read by any human or developer and then leak used for something else. And then another control we put on service control policy is that we're saying, hey, all the secret creation or write access only can be done through IAM role assigned used by Gatekeeper API. So this actually enforces that no one can create a secret out of band, out of the central API we want every secret to be created with. And then let's get to resource-based policy. On the resource policy, we set up a parameter using a control saying, all the secret in capital 1, we don't want any other organization. That means that, let's say Snowflake or some other company to access and read the secret owned by capital 1. Of course, we allow that exception if that's the reason we put on resource policy at a secret level, because we know there will be some case that capital 1 has some partner want to read the secret owned by capital 1. So we put that as part of resource policy so that if any, in that case, for that secret, we saying, hey, it's okay to be read by some other AWS organization. But for all the secret, unless explicitly saying it allowed to read by, to expose to external organization, that would be implicitly deny access to read the secret owned by capital 1. And then this is, the next control is the most critical one. And I bet, regardless, I think this is going to be useful for your case. That you want to put a policy on the resource policy on the secret saying only this list of IAM role can read the secret, but not anything else, right? So we do that by saying deny all principle except for this explicit list of IAM role. And this is very critical. So they ensure the secret really got used only by a Lambda function or an EC2 application you do. This is fundamental. We got to do this to ensure the secret not get used by unauthorized principle. And then let's get to identity-based policy. So at Capital One, we have an internal tool allow team to provision IAM role they need. But it have many things when it gets too sensitive that we don't feel comfortable for that tool to provision an IAM role for some service that is sensitive. But when I design this solution, by creative using the resource policy I just talked about, saying, hey, only this list of IAM role can read the secret, then we don't have to enforce that on the identity-based policy. So we actually allow any team to provision IAM role to read any secret they want. through self-service using this tool. So they don't have to wait for a central team to provision the iron role they need to read the secret. Even secrets are such highly confidential assets. And but rest assured, even though any team can provision iron role to read any secret, because we config the resource policy on the secret saying only this list of iron role can read that secret using our central management API, so that actually secret only also going to be able to read by only authorized application, but not by anyone, whatever they want. So lastly, we add an additional layer of access control that we call attribute-based access control. And this is done in this way. We have internal process for anyone when they create an iron role or create a secret. We want them to tag the iron role and the secret with their application name. And we have process to enforce that they cannot tag them with someone else's application. So by doing this, and also we put in the resource policy saying each application can only read the secret they own. Of course, we can allow exception because we also always know exception. But mostly the rule is the secret got tagged with a particular application name, then can be only read by the iron role that tag with the same application name. So this adds another layer of security. So let's recap what kind of, for all these multiple security control we put in place, what we have achieved. We set up the data, the parameter, so that no one else, no other company can read the secret owned by Capital One unless we explicitly allow them to do so, right? And we also enforce saying all the secrets got to go through the gatekeeper API so that they don't not get monitored. And then all the secrets created by gatekeeper API, we configure it properly to the standard of Capital One so that they are safe and secure from creation to deletion. And we ensure that human cannot access to the secret, so the secret never get leaked out by accident. And we also enforce that the secret and the secret creation, that only authorized application can read the secret by specifying saying all other application IMLO cannot read this secret unless this one that we know going to read this secret, right? And then we also put additional layer on top of that to enforce that application can only read the secret layer on, but not some other application on. So in summary, with this multiple layer of access control, that we feel our secrets are safe and secure all the time throughout their life cycle. With that, I'm going to invite my AWS partner, Akshay, to talk about how we introduce a framework so that each application can bring in their own logic to rotate the secret layer on. Thank you.
Am I audible now? Can you hear me now? Awesome. Okay, great. So that was a good start. I'm going to talk to you about secret rotation. It's a hotly debated topic. We all want to do it, but we can't do it. So let's start by understanding what rotation actually means. In a very simple language, secret rotation means programmatically being able to update the value of secret at a predefined cadence. And the question becomes, why do we need to update our secrets? The first reason for that is, let's take an example where you have a database secret which you're using in your application to consume, let's say, an RDS secret, and you have not set up rotation for it. Imagine a bad actor gaining access to that secret. In that scenario, the bad actor has access to all of your resources which are protected by that secret, and you do not have a way to mitigate that. If you had set up rotation for your secret, let's say with a 4-hour window or let's say a 1-day window, then that bad actor only has access to your resource for that defined time frame, because after that your secret value automatically gets updated. So a rotated secret always has a shorter blast radius than a long-lived secret. Second reason why we need to do rotation is compliance. All of you in your industries have various compliance standards that you have to abide by. For example, PCI DSS is one compliance standard that requires us to rotate our credentials at a very specific cadence, could be 60 days, 90 days, 30 days, depending upon your industry. And hence, you have to show to your auditors that your secrets are getting rotated periodically. And the third reason why you should rotate your secrets is, I'll stretch upon the first example. The bad actor has access to your secrets, and your secrets are, let's say, not getting rotated for another 30 days. If you have rotation set up, you can just invoke that rotation to ensure that your bad actor immediately gets access revoked from all of your database. And if you don't have your rotation set up, then you would actually have to go update your database with the new password, tell your applications that, hey, this is the new password that you have to consume to actually prevent that bad actor from making any further damage to your systems. So your incident response actually improves if you have rotation set up for your secret. Now that we know that rotation is so important for us, why don't we do it? Let me ask a question over here to you. I know initially Eduardo asked that how many of you are rotating the secrets. Let me further stretch on that and ask, how many of you rotate all of your secrets? Anyone? As I expected. Why do we not rotate the secrets? What we have heard from our customers is, it's difficult, it's tedious, it's complicated, and we don't want any downtime for our application. So let's see how Secrets Manager actually solves that problem for you. I'm taking an example over here where in your cloud, in your AWS account, there's an application running, and that application retrieves a database credential from Secrets Manager to connect to an Amazon RDS database instance. A very basic scenario. All you have to do is store your username, password in Secrets Manager, retrieve it in your application, and use it to build connection to your database. Notice on the right-hand side of the screen, I've mentioned the username as user A and password A, and that's basically your secret object. And that has been labeled with something called AWS current version. In Secrets Manager, we have this concept of version labels, and whenever you are retrieving a value of secret, you always retrieve AWS current version from Secrets Manager. And we'll see how this kind of helps us carry out rotation in a more graceful manner. When you set up rotation for your secrets using Secrets Manager deploys a Lambda function within your same environment, within that same VPC, within that same account to actually carry out rotation on your behalf. And when it's time to actually execute the rotation, Secrets Manager's rotation engine invokes this rotation Lambda function. Once invoked, this Lambda function then generates a new set of credentials for you, which is username B and password B. And notice that is marked with a version label as AWS pending. At this point of time, your application, when it fetches a secret from Secrets Manager, still gets user A and password A, which is AWS current. So even during the process of rotation, there is no downtime of your application. Once the Lambda function has generated a new set of credentials for you, it's going to go and set those credentials at the RDS database instance, your resource where the secrets are actually born. And then it's going to run a few checks to make sure that the new password actually works on the database. And once we have validated that, the rotation function will go back and update on Secrets Manager with the new secret value. At the same time, it's also going to swap the version label from user A to user B of AWS current. and mark user A as AWS previous. So at this point, when your application tries to retrieve the secret, it's still pointing to the same secret reference, but that secret value has now changed to user B and password B. This is how Secrets Manager is able to carry out the rotation process for you without having any downtime of your application. Now, this may still be a bit tedious, complicated. So let me clarify that. It takes 4 clicks to actually set all of this up, and you can do it from Secrets Manager console. Click on Enable Rotation, define your rotation schedule, give the name of the Lambda function, and submit. That's it. That's how you set up rotation on Secrets Manager and make sure all of your secrets get rotated. Another thing I'll call out over here, you would have noticed all of this lives within the boundary of one AWS account, which means all of your logging, all of your audit, and everything would happen within this account. And just before me, Sunny mentioned, we want to lifecycle manage these secrets from a central account while gaining the benefit of federated storage, having these secrets sit next to our applications in individual account. So let's expand on this use case and see how Secrets Manager's rotation engine actually scales to enable you do that. On the right-hand side, there's an application account where your application is running, pulling secret from Secrets Manager, connecting to an RDS database instance, the same thing that we talked about. In this scenario, when we set up rotation, instead of deploying a rotation Lambda function into the same application account, we can actually deploy a rotation Lambda function in the central gatekeeper account. That's where we are doing the lifecycle management of our secrets. And at the time of rotation, this rotation Lambda function gets invoked from Secrets Manager directly in the gatekeeper account, and it performs exactly the same set of steps to actually carry out the rotation process on your behalf. The benefit in this scenario is because your rotation Lambda function is deployed in a central account, you can do additional bookkeeping, logging, and everything for your entire organization from one central account. Not just that, because your Lambda function is sitting in your central account, you can actually set up alarms, monitors, even event bridge rules using the logs from this Lambda function to notify your application teams that, hey, your rotation has succeeded, or maybe your rotation has failed. You got to go fix something about that. So that gives you benefit of more additional controls to have enforced in your organization by having centralized rotation for your federated storage of secrets. Let's further stretch on this use case a bit. There could be scenarios where you would want to not have your central gatekeeper account have access to all of the resources which are in your application account. There could be some PII data, there could be some external systems that you would interact with, and you do not want central account to have access to all of that resources. How do we carry out rotation in that scenario? Let's see how that works. The same example, your application is running, but now in this example, your application actually talks to an external target system, and we do not want to give gatekeeper account access to this external target system. But we still want to do centralized rotation of the secret. So how do we do that? In this scenario, what we can do is, again, our rotation engine for Secrets Manager can read into a generic Lambda function that you can deploy in central account, and have your application teams actually build their own, bring your own Lambda, which they can deploy in local account. And being deployed in local account, this can actually access the secret from Secrets Manager and carry out rotation on your behalf. So Secrets Manager would invoke a generic Lambda function, and in a synchronous process, that generic Lambda function can actually call a rotation Lambda function, which is locally deployed in the account that can have access to your secret. And this local deployment of rotation Lambda function will fetch the value from Secrets Manager, go talk to the external target system, set it there, test it there, and report back to our generic Lambda function with the updated value, which has permissions to update Secrets Manager with the new value of secrets. And that's how, without giving access to our central account, we are able to even manage permission, we are even able to rotate secrets that are locally hosted or even from an external database systems that we don't want central systems to have access to. Again, you would have noticed, because a generic Lambda function is in our central account, we get to do bookkeeping, alarming, monitoring, and all sort of those things from our central account itself. With this, I want to invite on stage Eduardo to talk about the third key requirement that we had listed early on, which is around resiliency of secrets.
Thank you, Akshay. So far what we have been talking is two different aspects. So we have been talking about a centralized management of our secrets, but still having a federated storage. And then Akshay just talked about the two different ways that we are rotating Lambda. And so what we have so far is that we have the application, the gatekeeper application that's using Route 53 that talks to the Elastic Load Balancer. And the Elastic Load Balancer then is going to talk to the management Lambda function that in its turn is going to go there and create the secrets in Secrets Manager. And I'm calling that Secrets Manager instance as the primary instance there. And then the applications can go there and read and consume those secrets that are being created to that application. And likewise is that Lambda function is also talking to DynamoDB to persist that information for bookkeeping purpose. Now the question that I have for you is that how we can make that solution even more resilient. And as you know, is that this application has been deployed in two different accounts, as we have been explaining here. The gatekeeper account is responsible for the centralized management, and then you have the application accounts deployed there. And so to make that solution even more resilient, so what we are doing is that we are deploying across two different regions at Capital One. So we take that entire workload and deploy into a second region. And then the question that you might have is that how am I going to take all this information that's now being created into the first region into the second region? The answer is very simple. So we use the cross-region replication capability in both the Secrets Manager and DynamoDB. So what we have here is that whenever a secret is created into the primary Secrets Manager, we configure that to replicate that secret to the secondary region. And likewise for DynamoDB, we also use the cross-region replication capability of DynamoDB to take the items that are there in DynamoDB and propagate to the second region. This looks good, but let's look at some other scenarios here. So let's say that you deploy that solution active across two different regions, and I want to explore here two different scenarios that we have. So let's say that my application that's deployed there for some reason cannot talk to the Secrets Manager that is on that region. So one possibility that I have here is that application can do a cross-region call for the secrets that is available into the other region. So if I have any kind of issue between my application talk to the Secrets Manager on the same region, I have the possibility of doing a cross-region access to the other region. And even if there is some sort of disruption between the two Secrets Manager instances here, is that one good feature that we have from the Secrets Manager is as soon as that connection is reestablished, the Secrets Manager is going to take in all the secrets that have been created and propagate on its own back to the secondary region. So even if there is a rotation of that secret, the secret will be rotated always on the primary region, and then we'll let the cross-region replication go there and propagate that new value to the secondary region. We never rotate the secret on the secondary region. We always rotate on the region that the secret has been initially created. So key takeaways from our sessions here today is that by implementing this solution with a centralized management, we can have control and visibility and governance of the secrets that are created across all the different thousands of accounts that we have there. And we can have an out-of-the-box lifecycle management for the secrets by either doing a centralized rotation of the Lambda or bringing your own Lambda in the case that we have an external system that needs to have its secrets updated there. And the third thing is that building this solution with Secrets Manager, it's pretty easy, and you can really build a resilient and secure solution with that. So I encourage you to take a look at Secrets Manager as an easy way for you to go there and have a centralized way to take care of all the secrets that you have on your application. So we'll thank you for attending our sessions.